Padawans, it's Mrs. Angel with your lesson for today on simplifying variable expressions, combine like terms, or properties of exponents. Now, a lot of them look the same, but what you do to actually simplify them is completely different. So to follow along today, all you need is a blank piece of paper, maybe a whiteboard, nothing very fancy. So grab those notes and let's get started. We're going to start off today's video with just a quick review on combining like terms, which is something that we've already done before, but we haven't done it in a while, so let's just make sure we're fresh on that. So like terms are terms that have the same variable, but are also raised to the same power, have the same exponent. A lot of times we get confused with that second part and we start combining unlike terms. So we have an expression in front of us here. We have 2x plus 3x squared minus 5x plus 7 minus x squared. Go ahead and try to simplify it using combined like terms now. Well, let's see how you did. So the first step in combining like terms is to go in and actually identify the like terms. So which of these terms have the same variable with the same exponent? So I see a 2x leading on the front here. What other term also has just an x with no exponent or exponent of 1? Some might think that 3x squared is a like term with 2x, but because it has that exponent, it actually wouldn't be a like term. This minus 5x, however, that is a like term with 2x because they both have the same variable x. 7 doesn't have a variable in x squared, so it looks like 2x and negative 5x or minus 5x are like terms. The next term I see in this expression is a positive 3x squared. So which of the remaining two terms here also has an x squared? That would be this one here, this minus x squared. And then my final type of term here is just a constant. A constant is a term that does not have a variable. So we're going to go in here and we're going to combine these like terms. So I'm just going to go from left to right. 2x's minus 5x's would be negative 3x's. Notice I'm just saying that I have 2, I'm taking away 5, that leaves me with negative 3, and we still have x's here. Notice that the variable is still part of that term. Then we have a positive 3x squared minus an x squared. So that's like positive 3x squared minus 1x squared. That would be a positive 2x squared. Notice again, I'm keeping with my variable term. I still have x squareds. And then that positive 7 can't combine with anything, so we're just going to bring it down as a positive 7. Now I'm going to do some reordering here because we start to learn about polynomials. We like to put them in what's called standard form. So we put the term with the greatest power in front, meaning I want that x squared to be my first term, followed by my negative 3x, followed by my 7. So I'm just going to reorder this as there's my positive 2x squared, there's my minus 3x, and there's my positive 7. So I was able to go from a 5-termed expression down to a 3-termed expression, and all of my combining has been completed. Now let's take this review and put it into today's lesson. So the brunt of today's lesson is when you're given an expression and it has variables and constants and coefficients and all that, would you use combine like terms or would you use properties of exponents? Well, there's a couple ways to tell. First of all, in combine like terms, you know that you're going to be combining if you see sums and differences, because to combine means to add or subtract. And in our properties of exponents, you'll know that you're going to apply properties of exponents if you're looking at products or quotients or, frankly, also powers. But that one's kind of obvious. Obviously, if it's a power, you would use properties of exponents. So I'm going to give you an expression here, and you tell me where does it belong. Would you do combine like terms or would you do properties of exponents? All right, we have 6x plus x squared. Which one would you use here? Well, I see addition symbols, adding and adding, which means I would apply combining like terms here. I would look for the like terms and combine them. What about this one? I have 6x times x squared. Well, I see multiplication. And multiplication means I would be applying my properties of exponents. How about this one? X squared minus 3x squared. Well, I see subtracting, so that makes me think combining like terms, sums and differences. What about this one? We have x squared divided by, in parentheses, 3x to the power of 2. Well, not only do you see a division symbol, a fraction bar, I also see an additional power here, which means for sure would apply the properties of exponents. So if it has a sum or a difference, you're doing combine like terms. Product or quotient, you're going to apply the properties of exponents. Let's get into today's practice. Your turn. You have 4 expressions below. First, sort them into combine like terms or properties of exponents. Once they are sorted, actually go in and simplify the expression, applying whichever method you chose. Go ahead and do this now. Great, let's see how you did. First expression, 5x minus 8 plus x minus 3. That's a lot of pluses and minuses. That means this is definitely a combining like terms. Expression 2, 5x quantity to the power of 3. Not only is 5x a product, 5 times x, but it's also raised to a power. That's definitely going to be our properties of exponents. Expression 3, x squared minus x plus 3x squared. This one's kind of hard because we see these x squareds and automatically we jump to properties of exponents, but it has minuses and pluses. This is a sum and a difference, which means this is actually also combining like terms. And then finally, x squared times 3x squared. Well, that's a lot of multiplication to not be our properties of exponents. Let's go in and actually simplify. So number 1, find the like terms. I see a 5x and a positive x, and then I see a constant of negative 8 and a constant of negative 3. Now, normally we would read that as minus 8 and minus 3, but subtracting is equivalent to adding a negative, so I'm going to think of those as negatives. Let's combine. So 5x plus another x is 6x, and negative 8 and negative 3 makes negative 11. And there's nothing else I can do there because I'm not left with any other like terms, so I know that my expression is fully simplified. Let's hop over to our second expression, properties of exponents. Here we expand and simplify. So I have 5x, and notice that the entire 5x is inside of parentheses. That means this entire 5x will be multiplied by itself 3 times. So let's expand. That would be 5x times 5x times 5x, which is really 5 times 5 times 5 times x times x times x. Well, 5 times 5 is 25, times 5 again is 125, and 3x's mean x to the power of 3. Notice the difference in these two expressions. In the combined like terms, I still have 2 terms in my expression because some of them are not like. Whereas in the properties of exponents, all of that's simplified down into a single term, 125 x to the power of 3. Something to consider. Let's go on to number 3, x squared minus x plus 3x. So here I see a term that's x to the power of 2. Can I combine that with this minus x? No, that x does not have a power of 2, which means it is not a like term. I do, however, see a plus 3x to the power of 2, so those can be combined. And then my other term is just a minus x. So there's nothing I can combine that with. That's just going to come along for the ride. So here we go. X squared, that's 1x squared, plus 3x squared, combines for a total of 4x squared, and then minus that x. And there's nothing else I can do here because they're not like terms. And then over here, we see for number 4, our last one, we have multiplication. So I'm just going to start by expanding. X squared is x times another x. And then notice here, the difference in this expression is that the parentheses are outside of the exponent, which means you're only expanding x squared, not 3x times 3x. So this would be times 3 times x times x. So that simplifies to 3. And then there's, it looks like 5 total x's. 3x to the power of 5. Let's do a quick recap. So when you're looking at an expression and it's got variables and coefficients and all of that, you have to make the determination of if it's combining like terms or properties of exponents. The best way to do this is to look at the type of expression. If you're looking at a sum or a difference, you are definitely combining like terms. If you're looking at a product or a quotient, you are definitely looking at properties of exponents. So if it is combining like terms, just make sure you're only combining terms with the same variable and the same exponent. If it's properties of exponents, you can always expand and simplify or apply some of those patterns of adding the exponents, multiplying, subtracting, etc. That's it for today's lesson. I will see you next time.